Hello students, welcome to the second part. In the first part we did the definition of limits, how to associate functions with limits, but in this part we are going to find out the various methods with which we will find out the value of limit, whether it exists or not. So let's continue with the second part. So this is the topic of finding limits. Let's start with this. So these are the limits properties that we are going to see. As you have seen that in the very last part I told you that is a very important properties of limit, that you can find out the values of limit by using direct substitution. So what we are going to do, the first and foremost important thing while finding out the values of limit by direct substitution is that we have to check whether the value of the function is existing at that point or not. Suppose in the given function you have to find out the value of fx at x equal to c. So the first and foremost task involved in this condition is that you have to check what is the value of function fx at x equal to c, whether it's defined or not. If the value is defined, then only we can find out the value limit of this function using direct substitution, or we have to find out another value which will define the function at specific point x equal to c. In this case, suppose you will have different algebraic operations that will be taking functions such as addition of functions, subtraction of functions, multiplication of function or division of functions. For each and every case you have to consider in your mind that the functions must be defined at the value where you are finding out limits. Suppose this is fx and you have a function which is fx plus gx, and you have to find out the value of that at x tending to c. So fx as well as gx both must be defined at x equal to c, and they must give me a finite value to me. So to find out limits by using direct substitution will work in that case only whenever the function is defined at the value where we are trying to find out its limit. Okay, so as we have read the theory of finding out limits by substitution, so let's convert it into more firmer substance by using an example. Suppose the first example says I have to find out the limit of x tending to 4 and the function is root x. So what will I see in this case? I will check whether the function is defined at x equal to 4 or not. Yes, this is a square root and the values inside the square root must be positive. So I know that 4 is positive. So yes, the value x equal to 4 is inside the domain of this function. So let's put the value. So what we'll do, we'll substitute x for 4, and we know that root of 4 is going to give me a value that is 2. So this shows that the limit of the function root over x at x tending to 4 is 2. I think this is clear. So let's consider another example. But make sure that this example contains fractions. So there is a numerator and there is a denominator. Whenever we are going to deal this part, we must ensure first that the denominator's value at the given point is non-zero. So we can see that if I am going to put x equal to 6, the denominator is non-zero and this fraction is defined. So what we will do, we will directly put the value of x equal to 6 in both the numerator as well as the denominator, and what we will get, in the numerator 6 square, and in the denominator there will be 6 plus 3. So the numerator will be 36 and the denominator 6 plus 3 is going to give me a value 9, and the final value of this fraction will come out to be 4. So what we can say that limit x tending to c of this fractional function x square upon x plus 3 is 4. But be careful whenever quotient is involved, as just described by me in the last question. Suppose we take another example where we have to find out the limit of x tending to 2 and the numerator is x square plus x minus 6 and the denominator is x minus 2. Whenever we are going to put the value x equal to 2 in this numerator, the value is going to be 0, and the denominator, the value is going to be 0. So this is giving me a value which is 0 upon 0, and we know that it's undefined. So the real question exists whether the limit is existing or not, but the answer to this question says that limit exists. What we have to do, either we can use the graph of this or we can find out the factors of the quadratic equation that is present in the numerator. So what we will do, we will split the middle term and try to find out factors of this. What we can see is that the factors of this quadratic equations are x plus 3 and x minus 2, and in the denominator there is another x minus 2. So what we'll do, we'll cancel out both these values, and this function converts itself to limit extending to d extending to 2 and the value of x plus 3. So now this is a linear function, and I know that I can find out the limit of this function by using direct substitution. So what will I do? I'll put the value of x equal to 2 in this, and the final answer will be 5. So this was the method where we have found out the limit by using factorization of the numerator, but there is another method where we can find out the limit using graphs also. So hi students, now as if we have completed the topic, in case of any doubts and queries, what you can do, you can post your question for free on discussion board of Ask IITians. To do so, it's very simple process. First of all, you'll type www.askIITians.com in the address bar of your browser. Now you'll get towards this page, and in this page you'll find discussion board. You will click on that and it will take you to a page where you can ask your questions from the expert. First of all, you can select the category with which from where you want to ask the question. You'll post your question and then you'll click on the get answer button. We experts at Ask IITians will revert back to you in 24 to 48 hours with the answer of your question. I hope this process is clear. Well students, till now we have seen the definition of limits, how to find out the value of limits, if it's existing or not. In the next part which is going to come, we will see that how we can find the value of one-sided limit, and again keep on check on the function whether the value of one-sided limit is existing or not. So be tuned for the third part which is going to come, in which we are going to deal with one-sided limits and its various applications.